Alright, last problem as far as rotational equilibrium goes. Do a problem called the walk the plank problem. So here's a board here. I want more of the board supported by firm ground than the board over here. Let's say that this is 3 meters here, this is 2 meters here. It's not going to tip. Basically, if you want this thing to tip, more than half of it would need to be over on the other side, unsupported. Once the center of mass actually goes past the edge here, that's when you get tipping. Right now, the board center of mass is probably somewhere right there. So it's not going to tip. But if you put a person on it, and the person walks to the end, maybe they tip. And we want to find out exactly where they would tip. So in order to do that, let's give the board some mass here. Let's say that the mass of the board is 50 kilograms. Let's make our person 75 kilograms. And I'll put my person somewhere over here. Now, I actually don't know how far out he can go. But we do know what the weight of the board is, right? And the weight of the board would be 50 times 9.81, which is 490.5. And that's directed right here. You got 490.5 there. The person, their weight is 735.75. But we don't know how far out he's going to go before it starts to tip. A lot of people go, well, where's my pivot point here? In order to see the pivot point, what you got to do is you got to kind of visualize the tip itself. You know, if you walk too far, what would end up happening is it would look like this. So your pivot point is right there. We're going to make this our pivot. So visualizing the tip kind of helps us do that. Now, what we're going to do is just set the torque equal to 0, the net torque acting on the board. Because if we do that, that'll give us the farthest spot that our person can go. So, sigma tau equals 0. If you take a look with respect to this pivot, that's clockwise, that's counterclockwise. So I'll do the counterclockwise one first. 490.5. How far away is this? Well, we got to do a little visualization here. This is 2.5. That's 2. That's got to be 0.5 away from the pivot. And then the person, I don't know where he can go. But he's going to generate a negative torque, 735.75. And let's just say we're going to solve for R here. So R is our only unknown. Let's see what it works out to. What I end up getting is 0.333 meters. Now this is an answer that is from the pivot point. So he can walk 0.33 meters to the right of this pivot right now. Anything beyond that, his torque will then be greater than the torque generated by the weight of the board, and this is going to begin to tip. Now, if we had gotten an answer that was, say, that was greater than 2, what I can conclude would be that he could walk as far all the way to the end of the plank without having to worry. But the fact that we got some value within this range here, that means that the board will tip, and it'll tip once he steps beyond that point.